Hello. Today we will continue with our chapter 16 on capacitors. So what did we learn last time? We learned last time that if we have a parallel plate capacitor which has an area of each plate equal to A and the separation between the two plates is equal to D, then the capacitance of this capacitor is some constant epsilon times A, which is the area, divided by the D. Okay, now if we connect this capacitor with a battery of voltage V, then we will have a total charge Q on the positive side of the on the positive plate of the capacitor Q equal to C, which is the capacitance times the voltage V. Okay, now when we connect the capacitor into a battery, there will be a flow from the positive plate to the negative plate. So it will create an electric field E, which is equal to the voltage V divided by the distance D between the two plates. So that's the third formula. And the fourth formula is that these capacitors are used to store energy, and the energy is equal to half QV. Okay, then we can use instead of QCV, so we get half CV square, or instead of VQ over C, so we get half Q square over C. Today, we will deal with combinations of capacitors. So why do people make combinations of capacitors? Because, for example, I will buy a bunch of capacitors that have different capacitances, and I want a particular value of a capacitance as a result of combining these capacitors. So I will combine them in a certain way so as I can get a particular capacitance. Now, capacitors can be either the easiest two ways to combine capacitors is either in parallel. So for example, in this case, we have two capacitors. One of them has capacitance C1. The other one has a capacitance C2. Okay, and they're connected in parallel with a battery V. Here, I have to remember that if they are in parallel, then the voltage across each capacitor is the same as the voltage V across the battery. So V equal V1 equal V2. That's why here I did not call V1, V2. I just called it V. And for Q, there will be Q coming from the battery, and it will split into Q1 and Q2. So Q has to do with the current, if you can remember the current. Okay. Now, if I combine these two capacitors, they will give me C equivalent, okay, which will have voltage V, and it will have Q, which is a Q1 plus Q2. Now, V is equal V1 equal to V2. Q is equal Q1 plus Q2. I put instead of QC equivalent V. Q1 is C1 V1, Q2 is C2 V2, but V is equal V1 is equal V2. So I get C equivalent is equal C1 plus C2. Okay, this equation you can just memorize it. You don't have to learn how to derive it, although knowing how to derive it will help you solve other parts of the question. Okay, so again, when they are in parallel, the voltage is equal, but the Q is additive. So in order to get the Q across the whole circuit, it will be Q1 plus Q2. Okay, and I get the C equivalent to be C1 plus C2. Now, another way to combine the capacitor is in series. I think you remember this. So when they are in series, the Q will be equal. Okay, so the Q that comes from the circuit will be equal. So Q1 and the Q2 are equal to Q. It has the first capacitor has capacitance C1, the second capacitor has capacitance C2. Here the voltage is additive because the voltage is V1 plus V2. So if I start with V equal V1 plus V2, instead of V, I will put Q over C equivalent, because here remember, Q is equal CV. Okay, so V is a Q over C equivalent, V1 is a Q1 over C1 plus Q2 over C2, but Q equal Q1 equal Q2. So I get the equation 1 over C equivalent is equal 1 over C1 plus 1 over C2 when they are in series. And this is C equivalent. It will have voltage V, which is V1 plus V2, and it will have VQ, which comes from which is C equivalent times V. Okay, let's do some exercises. 4 capacitors are connected in parallel with a battery. Determine the capacitance of the single capacitor that is equivalent to the capacitor. So we have to get the equivalent for all these 4. So all these 4 are in parallel. So C equivalent will be C1 plus C2 plus C3 plus C4. So C equivalent is equal C1 plus C2 plus C3 plus C4. And this is equal 3 microfarad plus 6 plus 12 plus 24. And this will give us 45 microfarad. Okay, you can also turn it to farad, no problem. So this is part B, part A, sorry. Now, part B, determine the charge on the 12 microfarad capacitor. So here we have to remember that Q is equal Q1 plus Q2 plus Q3 plus Q4. So if I want Q3, so let's call these C1. C2, C3, and C4. Okay, so determine the charge on the 12 microfarad. So Q3 is C3 times V3, which is equal, C3, I have it, 12 microfarad times V3 is V, because these are in parallel. So this is a 12 times 18, and this will give me 216, sorry, 216 microcoulomb. Okay, part C, determine the total charge contained in this configuration. So the total charge Q is C equivalent times V. This is equal to 45 micro. So remember that we will have micro times 18, and this will give us 810 microcoulomb. Of course, here you can turn everything to 10 power minus 6. There is no problem. Finally, part D, determine an expression for the fraction of the total charge contained on one of the capacitors. That is, I want to get, for example, Q1 over Q total. Okay, so what is Q1 over Q total? This will be, if we get, we did the Q3, for example, so we get Q3 divided by Q total, let's call it Q. So this is C3 V3 divided by C equivalent times V, right? And this is equal to what? V3 and V are equal because these are in parallel. So we divide by it. So I will get Q3 by Q is equal C3 by C equivalent. And for any Q, so let's say Qi over Q, which here I mean by Q is a Q total or Q equivalent. So this, let's call it Q total, or just Q, which is for the whole circuit. Okay, you can call it Q total, no problem. So this Q here is also Q total. So this is the Qi by Q total is equal to Ci divided by C equivalent. So if there is an additional question here, E, let's say deduce the charge on C4. Since I have to deduce, then I have to use part D. So I have to say Q4 over Q total. Sorry. So part E, deduce the value of Q on C4. Okay. So I will say Q4 divided by Q total is equal C4 divided by C equivalent or C total. So Q4 will be equal to C4, 24 microfarad. Okay, so 24 microfarad times the Q total. So there will be cross multiplication. So times the Q total, which is in part C, that is 810 microcoulomb, divided by C equivalent, which is 45 microfarad. So one of the micros will disappear and I will get Q is equal 24 times 810 divided by 45, and this will be 432 microcoulomb. Okay, so when it's in parallel, you have to remember this formula. We will be using it in the last question. When they are in series, I don't care because the charge is the same across all the capacitors. But when they are in parallel, then I have to remember this formula. Okay. So four capacitors are connected in series in a battery. Okay, so let's also call them C1, C2, C3, and C4. Okay, so calculate the capacitance of the equivalent capacitor. So here I have to use the formula 1 over C equivalent. These are in parallel. This is equal 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C4. You don't try to do any math here, okay? Just use your calculator. So this will give you 1 over 3 e to the minus 6 plus 1 over 6 e to the minus 6 plus 1 over 12 e to the minus 6 plus 1 over 24 e to the minus 6, okay? This will give you 0.625 e to the 6. Then in order to get C equivalent, you flip it. So C equivalent is equal 1 over 0.625 e to the 6. On your calculator, you put 1 over answer, and you will get this to be 1.6 e to the minus 6 farad or 1.6 microfarad. Okay, part B. Find the charge on the 12 microfarad capacitor. So here, these are in series. So Q equal Q3, and this Q is the Q total, equal to Q3, or let's say Q3 is equal to Q total. And what is Q total? It is C equivalent times V total. So this is 1.6 e to the minus 6. (1.6 e to the minus 6 times the total, which is 18, and this will give me 28.8 e to the minus 6. Sorry. E to the minus 6 coulomb. Part C, find the voltage drop across the 12 microfarad. So Q3 is equal C3 times part C. Q3 is equal C3 times V3, implies V3 is equal Q3 divided by C3 . This is equal Q3 28.8 e to the minus 6, which is the same as Q total, divided by C3 12 e to the minus 6, and I get the answer 2.4. Okay. So again, when they are in series, the Q is the same. So Q coming from the circuit is the same as a Q1, Q2, Q3, Q4. That's why here we said Q3 is a Q total. But the voltage is not the same. So the voltage will be Q over C. Okay. When in parallel, the voltage is the same when they are in parallel. When in parallel, the voltage is the same. So I have V1 equal V2 equal V3 equal V4. Okay, C equivalent is additive. And the Q, in order to get the Q, I have to use this formula when they are in parallel. So QI over Q total, it's not QI equal Q total. That's in series. In parallel, QI over Q total is equal CI over C equivalent. Now, let's do one more question. So consider the combination of the capacitors shown in the figure. All capacitances are in microfarads. Okay, so calculate the equivalent capacitance between A and B. Let's first give them names. So this is C1. This is C2. This is C3. This is C4. This is C5, and this is C6. Okay. Now, what do we observe directly? We observe that C1 and C3 are in parallel. C5 and C4 are in parallel. So I start. C2 and C3 are in parallel, implies I will call it C23. That is the equivalent of 2 and 3. It's equal C2 plus C3, which is 1 plus 3. This is equal 4 microfarad. Okay. Then C4, same thing. C4 and C5 are in parallel, implies C45 equals C4 plus C5, which is equal 6 plus 2, which is equal 8 microfarad. Okay, so I got rid of this and this. Now look how it will look like. Okay, so 1 and 3 are in parallel. So I have 2 and 3 are in parallel. So now I have C23. 4 and 5 are in parallel. So now I have C45. Now look at C1 and C23. How are they arranged? They are in series. Okay, and C45 and C6, they are in series. So C4 and C23 are in series. Okay, implies, so here I have to use 1 over C234 is equal 1 over C4 plus 1 over C23. From here I get C234 is equal to sorry, not C234, C123. So this is C1 and C23 are in series. So this is C123 is equal to C1 plus C23. So C123 is equal to 2 microfarad. Okay, so here I just choose this. This capacitor and the equivalent of C23 are in series. Okay, So I use this. Now I will do the same for C45 and C6. Okay, they are also in series. So I have C45 C45 and C6 are in series, implies C456 is equal 1 over C45 plus 1 over C6 1 over C456 implies, just plug the numbers and I will get C456 is equal to 4 microfarad. Okay. Then so I got the C123, I got the C456. Now these two together, how are they connected? They are in parallel. So C123 and C456 are in parallel, implies C equivalent is equal to the summation of them, C123 plus C456, and this will give me 2 microfarad plus 4 microfarad, and this is 6 microfarad. So this is C equivalent. Okay. Okay, if a 12-volt battery is connected across the system VAV, so I have the total V across the circuit is 12. Find the charge on the 4 microfarad capacitor. So we want to get Q1. Okay, so here I need to get Q1. What do I know? I know that the Q1 is equal to Q23 because these two are in series, and this is equal to Q123. So I know that Q123 is equal to Q1 is equal to Q23. The same thing down. The same thing down. I have Q456. Q456 is equal to Q4 is Q45 is equal to Q6. Okay, because these are in series. And what do I know? I know that the Q123, because Q123 and the Q456 are what? So this is here Q45. Here there is a Q45. And here there is a Q6. And in the whole thing, there is a Q456. Okay. So what do I know about Q123? This Q123 and Q123, Q123 and Q. Let me actually write these things here. So this is part B. C1 and C23 are in series, implies Q123 is equal to Q1 is equal to Q23. That is the total charge in this part of the circuit is equal Q1 is equal Q23. Then C4, 5 and C6 are in series, implies Q456 is equal Q45 is equal to Q6. Now, Q123 and the Q456 are in parallel. Over here, I have to use the formula Q123 divided by Q total is equal to C123 divided by C total implies Q123 is equal to C123 times the Q total divided by C total. Okay, what is C123? It is 2 microfarad. So this is 2e to the minus 6. What is the Q total? Q total, I can do the calculation here. Q total is equal C equivalent times V, which is equal, C equivalent is 6 e to the minus 6 times the total V, which is 12. So Q total is 7.2 e to the minus 5 coulomb. Okay, so I come to this equation. So implies Q123 is equal to e to the minus 6 times 7.2 e to the minus 5 divided by C equivalent or C total, which is C e to the minus 6. And this is 2.4 e to the minus 5 coulomb. Okay, so this is a Q123, which is the same as a Q1. So Q1 is equal to 2.4 e to the minus 5 coulomb, because the question is find the charge across the 4 microfarad, that is a Q1. That is C1, so I have to calculate Q1. The last part, find the voltage drop across it. So here I have to remember that Q1 is equal C1 V1, implies V1 is Q1 over C1, which is Q1 is 2.4 e to the minus 5 divided by C1, which is 4 e to the minus 6, and I will get 6 volts. Okay. So in this question, we worked with a different combination of capacitors. In the remaining lectures of this week, we will be doing more like this, so as we learn exactly how to solve such problems. So bye-bye for now.